Alright. Hey guys, let's go start our lesson. Let's go day 3. So we talked about factoring. Factoring is a huge piece. If you're still struggling with factoring, guys, get some help on it. Come in after school. Go to math resource. Do something, right? Factoring is going to be used throughout this whole unit. So if you don't know how to factor, you're in a lot of trouble. Now, today we're talking about rational expressions. We're talking about simplifying rational expressions. Before we can simplify them, though, we need to know what they are. A rational expression is the same as what we call an algebraic fraction. What that means is they're just polynomials in the numerator and denominator. And what that means is that we have numbers, we have variables, we have operations throughout our fraction. Alright, so we have x over 2, we have 4x over 3y, 2x plus 1 over 5. We can have any combination of numbers, variables, and operations in our fractions. That's what makes it a rational expression or an algebraic fraction. Now, when we have any sort of fraction, not just any algebraic fraction, just a fraction in general, the denominator cannot equal 0. Why is that? What happens to a fraction if it has a denominator of 0? It's what?
It equals 0.
It doesn't equal 0. In your calculators right now, everybody get the calculator out. You don't have it out.
Error.
Do 3 divided by 0.
Error.
Error 4.
Do it right now.
3 divided by 0. I get error.
You get error. You get error, right? It's an error because it's undefined. You cannot divide by 0. So, we cannot have a denominator of 0. So when we are simplifying these things, these rational expressions, we're also going to look at what we call for restrictions. Restrictions are anything that would make our denominator equal 0. Because we can't have that, right? So when we do a problem, we're going to say, hey, x can't equal 3. Does that make our denominator equal 0? That would be our restriction. The first one here, 5 over x. I know it's not on your paper, so just follow along. 5 over x. What can x not be?
0.
0. So if I were going to write a restriction, I would write x cannot equal 0. So at the end of our problems, when we do these restrictions, that's what we're going to write. X can't equal 0. If I were to do this next one, x plus 4 over x minus 5. If I look at the denominator, what value of x would make that equal 0? If x is equal to?
Negative 4.
On the denominator.
Oh, the denominator. Oh, 5.
5, right? If I put 5 in for x, I get 5 minus 5 is 0. So I know x cannot equal 5. That would be my restriction for that problem. Anything that's going to make your denominator equal 0 is going to be a restriction. Alright? Yes? Does that kind of make sense?
Yes.
And we can't let our denominators equal 0. Alright, moving on. Just simplifying. When we simplify, we start by reducing fractions. Now, before we even start simplifying, you should always try and factor. Factor first, and then simplify. Alright, because we can only simplify like terms in the numerator and denominator. So if I look at the first problem, 2x to the 4th y cubed over 35x cubed y. Can I factor those at all? No, right? They're terms. They're 20x to the 4th y cubed. That's a term. I can't factor that. 35x cubed y. It's a term. I can't factor it. What I can do though now is simplify these. Well, 20 over 35. Can I take something out of both of those? I can take a 5 out, so I'm going to do that. So if I take a 5 out of 20, I'm left with 4. Take a 5 out of 35, I'm left with 7. Okay? What about like x to the 4th over x cubed? Can I take out a certain amount of x's? X to the 3rd, I can take 3 of them out. On the bottom, what am I left with?
Y.
What?
7y.
Well, 7y right now, yeah. But top I'm left with x, right? X cubed cancels out. Now, it doesn't just cancel out, it doesn't just go away. What does it actually become?
1.
It becomes a 1, right? If I do x cubed divided by x cubed, technically it becomes 1. But do we have to write that out?
No.
No, right? Anything times 1 is 1. What about like y to the 3rd over y? What can I take out of both of those?
Y.
Y. So on the bottom, it technically turns into 1. On the top, I'm left with y squared. Does that make sense, those three steps we just did? Okay, so now I'm just going to rewrite it. 4xy squared over 7. Can I simplify anything else?
No.
No?
No.
Okay, so that's my answer then. Okay, now it also asks us what are some restrictions that we would have? If I look at the ending of my thing here, my denominator is just 7. Is there anything that's going to make 7 equal 0?
-7.
Well, no, because there's no variable, right? If I don't have a variable, then I'm not going to have a restriction. However, when we're doing a problem, ladies and gentlemen, we're not just looking at our ending point. We have to look back where we began as well. Do I have variables over here?
Yes.
Yes, I'm going to have a restriction for each of those variables. X cubed. I don't want that to equal 0 because 0 times anything will be 0, right?
Mhm.
Well, what would make x cubed equal 0? If x equaled, what would make that be true? If x was
0.
0. So my restriction for that then is x cannot equal 0. Same thing for the y. What would make y equal 0 if y was
0.
0? So that's another restriction. Y cannot equal 0. Those are my two restrictions for the problem. So not only do you need to look at where you end up, but where you begin. Any questions on this? I know this is confusing. Alright, that's why we should be paying attention and asking questions. Alright, our next one. 2x minus 7 times 3x minus 5 over 3x minus 5 times x plus 14. Guys, it is really important. We can only cancel whole terms here. What I mean by that is 2x minus 7 is a whole term. 3x minus 5 is a whole term. To be able to cancel either of those, I need that whole piece in my denominator somewhere. To cancel 3x minus 5, I need that whole piece in my denominator somewhere. If I have addition or subtraction between any terms, I can't just cross things out like this. That is not okay. 3x minus 5 is one whole term. So if I'm going to cancel that whole thing out, I need that whole piece. Now in this case, I do have that. I can take 3x minus 5. I can take the whole thing out of both the numerator and denominator. I'm left with 2x minus 7 over x plus 14. But that is as far as I can go. I cannot simplify 7 over 14. Because they are each a part of a whole term. X plus 14 is one whole term. If I have addition or subtraction in it, so like I have 2x minus 7, that is one whole piece. In order to cancel any part of it, I need to cancel the whole thing. X plus 14, that is one whole piece. In order to cancel any part of it, I need the whole thing in the opposite numerator or denominator. Alright? Does that make sense?
Yes.
So that is my final answer for this problem. 2x minus 7 over x plus 14. Because I can't simplify it any farther. If I'm simplifying things, that means they have multiplication in between them. Like we had here. Alright. We have two restrictions for this problem. How we find them is we take each piece of our denominator, right? We said we'd look back where we started as well. Take each piece, 3x minus 5. Set it equal to 0. Take x plus 14. Set it equal to 0. If I solve both of those for x, I should get my two restrictions, because that'll tell me what would make my denominator equal 0. Yes? Oops, trying to extend. How do I solve 3x minus 5 equals 0? Add 5. 3x equals 5. And I divide by 3. I get x equals 5/3. That is my first restriction. If I plug 5/3 into here, that's what would make it equal 0. So I know x cannot equal 5/3. X plus 14 equals 0. Same thing, subtract 14. X equals negative 14. If I plug negative 14 into this part, it's going to equal 0. We can't have that. So that's one of my restrictions. X cannot equal negative 14. Alright, we've done 2 problems. What questions do you have? None? Okay, we can try another one. Okay, so these next ones, like I said before, we're going to factor everything first. Factor it all first. My numerator here, can I factor anything there?
7. Oh, yeah, 7.
7x squared. I'm taking out a GCF, right? It's not a difference of perfect squares. It's not a three-piece, not a trinomial. So I'm just going to take a GCF out. Take out 7x squared, I'm left with x minus 3 over 6x squared. Does everyone understand that part at least?
No.
Yes.
Factoring out.
Yes.
So all we're doing here, Aiden, is we're factoring a GCF out of our numerator. So we want to get everything as factored as possible first before we start simplifying. So if I know out of 7 and 21 I can take a 7 out of both. I know out of x cubed x squared.
I got it.
Take an x squared out.
I thought you just didn't put the 7 in. No, I got it now. Yeah.
Okay? Alright, is there any like terms that I have in my numerator and denominator that I can simplify?
X squared.
X squared, right? I have multiplication between all these pieces, which means I can cancel any of those pieces out. I'm left with 7 times x minus 3 over 6. Can I simplify anything else in this fraction? No, right? I cannot do the 3 and 6. X minus 3 is one whole term, so if I'm going to cancel any part of it, the whole thing has to go, which I can't do. Alright, if you want to leave your answer like that, I'm perfectly okay with it. That's a perfectly fine answer for me. Now, normally I will, however, distribute that 7 back through. I'll make it 7x minus 21 over 6. If you leave it like that on a test, it will not get marked wrong. I'm perfectly okay with that. Okay? Yes, sir?
So the second answer was 7x minus 21. What would be the 21?
So I just distributed that 7 to both pieces. Okay? Alright. Restrictions for this problem. Do we have any?
X can't equal 0.
X can't equal 0, right? If I plug a 0 in at the beginning here, what am I going to get?
0.
0, and I can't have that. So x cannot equal 0. Yes, Miss Baker?
If there's multiplication, will the restriction always be 0?
Yeah. So if it's always like 6 times just like a variable, or any number times a variable, it's going to be 0. Now if you have separate pieces like we'll have in the next one, then we got to do a little addition or subtraction. Okay? Alright, the next one, same thing. Factor first. Factor as much as possible first. X squared minus 4 over x squared minus x minus 2. Hey, that numerator's got a special name. Does anyone remember what it is? It starts with a D. No?
Just denominator.
It's a difference
Difference
of perfect squares, right? X squared is a perfect square. 4 is a perfect square. A difference of perfect squares. Well, if it's a difference of perfect squares, I can take the square root of both of them. Square root of x squared is x. Square root of 4 is 2. add and subtract 1. So x plus 2, x minus 2. My denominator then, I need to find numbers that multiply to negative 2, add to negative 1. 1 and
Negative
1 times what gets me
Oh,
negative 2?
2.
-2.
one.
Negative 2. Alright. Now that it is factored, I can start simplifying. Well, do I have any like terms in my numerator and denominator?
Negative 2.
X minus 2
Yeah.
and x minus 2. I can cancel them. I'm left with x plus 2 over x plus 1. Anything else I can simplify?
The X's go away? No.
Why can the x's not go away?
Because they're their own thing.
Because they're attached, right? They're attached to the 2. They're attached to the 1. It's a whole term. X plus 2 is a whole term. X plus 1 is a whole term. So no, I can't cancel those x's. Right? That is the most common mistake on the assessment in this unit, is people try and cancel those x's. Don't do it. Don't fall for it. Right? X plus 2 is a whole term, so the whole thing needs to be top and bottom if I'm going to cancel any part of it. So that's my answer. Now I'm going to have 2 restrictions for this problem. Can anyone tell me one of them? What can x not equal that would make our denominator 0? If I look at my 2 pieces,
Negative 2.
x cannot equal, not negative 2, but
Positive 2.
positive 2, right? 2 minus 2 would be 0. So x cannot equal positive 2, and x cannot equal,
Positive 1. No.
what plugged in here?
-1.
Negative 1. Hey guys, if you have trouble just looking at it and seeing that, like we did before, take each piece, set it equal to 0, and solve for x. X equals negative 1, so that's one of my restrictions. X minus 2 equals 0. Add 2. X equals 2. That's another one of my restrictions, alright? So if you have trouble with that, set each piece equal to 0. Alright. Let's try. I gotta do this. Stupid board won't work. Let's try the next one. X squared plus 5x plus 6 over x plus 3. What's my first step? Always. Factor first. So, I can factor this trinomial, right? The 3 pieces, I can factor it into 2. What multiplies to 6 and adds to 5?
3 and 2.
3 and 2. So x plus 3, x plus 2 over x plus 3. Do I have any like terms? X plus 3, numerator and denominator.
X plus 2.
So I'm left with just x plus 2. Alright. Be very careful here. We're looking for restrictions. Does my n have a denominator even? No. But my beginning does. So I still have a restriction here. What can x not equal? Negative 3. Right? If I take x plus 3, set it equal to 0, subtract 3, we know negative 3 would make it equal 0. So that's our restriction. X cannot equal negative 3. Yes, Ms. Baker?
How do you know which one to take the restrictions on?
Yeah.
We are always taking the restrictions of the denominator.
That's it?
That's it.
Just a
Because if you plug in your calculator, you do 0 divided by 5, you get 0. That's fine. We just can't divide by 0. So it's always the denominator. Yes?
Okay, in the top part, there's 3 x's, and then we put 2 in the next part. Where's the third one go?
Up here?
Yeah, there's 3 x's.
So we factored it, right? If I factor it out, I should get 2 separate pieces. And then when I FOIL it, I'll get back to x squared and x.
So you need to multiply.
Okay. So when we factor, right? What times what will give me x squared? X. What times what gives me 6? 3 and 2.
So what happens to the 5x?
So the 5x is when we do the outside and the inside of our FOIL. Right? So we get 2x plus 3x gives us 5x. Okay? Alright, let's try. We only have a couple minutes. Let's look at this one quickly. X squared minus 2x minus 3 over x squared minus 5x plus 6. Factor first. If I factor the numerator, I get x minus 3, x plus 1. If I factor the denominator, I should get x minus 3, x minus 2. Do I have any like terms in the numerator and denominator?
Minus negative x minus 3.
X minus 3, so those both will cancel. I'm left with x plus 1 over x minus 2. Is there anything else I can simplify from that?
No.
No, right? Do not cross those x's off. X plus 1 is a whole term. X minus 2 is a whole term. And when I look for my restrictions, I know if x equals 3, that first one equals 0. So x can't equal 3. If x equals 2, the second one equals 0. So x cannot equal 2. Alright? Alright. I'm going to hand out the homework. I know there's a bunch we didn't get to.